make the assumption here that the issue with solving this problem is deciding how to set up the integral rather than evaluating the definite integral once you've got it. Over here, I've actually graphed the region that's going to be revolved. For part A, we're going to revolve around the x-axis. And so you have to decide whether to use the shell method, the disk method, or the washer method. Well, when the axis of revolution is right on the boundary of the region being revolved, you can use the disk method. And you want to picture like a thin little disk here being revolved around the axis of revolution. And you're going to get a disk that maybe looks something like this. And you want to find the volume of that disk and then integrate from 0 to 1. So this is like the radius of that disk, and we got to square that disk. So there's your integral right there. And I've actually evaluated it, and we see that pi over 5 seems to be the correct answer. If I go to board 2, where we want to revolve about the line y equals -3, it still looks like we're going to go perpendicular to the axis of revolution, but now we're going to use the washer method, which means outer radius squared minus inner radius squared, still integrating from 0 to 1. What is the outer radius? It's the distance from this point to this point. But so this distance right here for some number x is x squared. And this distance is 0 minus a -3. So the total distance is x squared minus a -3. Top minus bottom. It's one way to think about it. So that's the outer radius, x squared plus 3. Of course, we got to square the outer radius squared, minus the inner radius squared is the distance from the axis of revolution to the inside portion of the region being rotated. Well, that's just 0 minus a -3, or 3. So 3 squared. If you I think it is 6x squared, find the antiderivative, etc. And it looks like 11 pi over 5 is the exact value. And finally, on board 3, if we're rotating about the line x equals 3, it looks like the shell method is what we're going to want to do. So you draw a shell that's parallel to the axis of revolution, and we know that the integral to set up this distance represents the height of the shell, which is just x squared, and the average radius is the distance from the axis of revolution to the center of the shell. So that distance we can think of as the right x coordinate, which is always 3. Take away this distance right here, which is x. So 3 minus x will be the average radius, and that's what this is right here. So it's height of the shell times the average radius multiplied by 2 pi, and we're integrating from 0 to 1. And if you distribute the x squared, find the antiderivative, etc., looks like 3 pi over 2 is the correct answer. Okay, and I'm going to include in my answer the link to the Desmos graph so that you can take a look at it if you so desire.